My name is Gino Kelly, and I actually hail from Florida. This is my second time in Argentina, and I'm always real thankful when I get invited back because I love coming here. Just a little bit about my background. I'm a former secondary math teacher, and I did that for many years, working primarily with disadvantaged youth. So these were kids that are typically in danger of not graduating from school. So the first challenge was getting them to school. The second challenge was keeping them in school. And then the third challenge, oddly enough, was teaching them mathematics. So it was a trifecta of a challenge. But in my years, I've also taken a keen interest on technology and how technology can help serve some type of a meaningful purpose in terms of how we use it in a classroom. And so what I'd like to share with you is just some examples and some ideas that in my time I've come across that I think can help in terms of mathematics instruction and how we can enhance that instruction using technology. Specifically, I've been using these technologies now for the last few years and really thinking about ways in which these technologies can help support teachers not only become more efficient in their teaching, but also to help them create lessons that kind of deepen the understanding of mathematics for students. So we're going to be using these devices here alongside some of the stuff here on the board. So I'm just going to hand these out to you guys. So we're going to look at teaching and learning in general and think about really, what does that mean in the context of mathematics and then within the subcontext of these particular technologies. So let me start you off with a little personal story. So I have two younger brothers that are both in college, and one of them actually took a calculus class last semester. And he calls me at the beginning of the year and says, "Can you help me? Right? Can you help me with my homework and stuff?" And so I said, "Sure, not a problem. We'll get on Skype and I'll help you with your homework problems, right?" And so we did that throughout the semester, and came across this problem that his professor had given him. And if you guys remember calculus back in the day, this is on Riemann sums, which is a bit obscure. You can forget about it real quickly. And I had forgotten because I hadn't done calculus in a couple of years. So I said to him, let me go home, or let me go back and figure this problem out, so I can refresh my memory. And then I'll call you back. So I hung up, and I spent literally 3.5 hours trying to work this problem out because I just couldn't remember all this stuff. I had to kind of relearn it. So here's the problem, and this is all the work that I did to try to figure out the solution. And after 3.5 hours, I finally figured out the solution. Now it's static. So I called him. I said, "Hey, get on Skype because I figured out the problem. I'm going to show you how to do it." And he says to me, "Oh, it's okay. I figured it out already." And I said, "You figured it out?" He's like, "Yeah." I'm like, "Oh, well, how long did it take you?" It took me 5 minutes. And I said, "Well, you have to show me because this might be some new method that your professor came up with that I don't know about." And he says, "All right, sure." So we get on Skype, and I go, "So how did you solve the problem?" He said, "Oh, it was real simple. I found this website called Yahoo Answers, and I typed in my question. Okay, now if you notice, the question is exactly as his teacher asked it. Okay, with the picture. Here's the picture, and then all he did was just found some guy who had given him the answer. So he copied down the answer and put the solution, got it right? To which my response to him was, among other things, right? How are you going to do this on the test? You can't get online on the test. "Oh, it's okay because it's easy because the way he teaches, he just memorizes steps." So I memorize the steps, and he's just going to change the numbers. And when he changes the numbers, I'll know the steps, and so I'll get it right. And at that point, I thought to myself, well, that's not really learning, is it? It's not really teaching. And this is some of the challenges that teachers face today, right? Is that students have available information and available answers everywhere. It doesn't matter, right? What they have. So it's not a sense of giving them questions that simply ask them to regurgitate information or memorize information because they can find the answers really simply. The question now becomes is how do we instruct in a way that helps them think more deeply about the mathematics that's going on, right? And more importantly, how do you connect that to everyday life, right? Which is a huge undertaking. So let me start you off with a math problem. So we're going to do this together, okay? So here's a question that I'd like to propose to you. And it says, we're at a rock concert, and we're on a field that's rectangular in shape. The dimensions are 100 meters by 50 meters, okay? Now the concert was completely sold out. So your challenge is to tell me which one of the following estimates that I'm about to show you, okay, or numbers, excuse me, would be the best estimate for the total number of people attending this concert. So I'm going to give you a little bit of time, okay, and when you think you've come up with a solution, go ahead and use your devices to input your answer, okay, A, B, C, D, or E, okay. Which one do you think is the best estimate for this, this particular problem? So which one of these numbers? Just put in the number. And then your answer once you figure it out. So most of you said 20,000. One of you said 3. So that must have been, well, let's see, 3. You meant C, is what you meant. Okay, very good. All right, very good. So that's one way to give a problem to math students. As a matter of fact, this is typically the way we give problems to math students, right? When you look at math books, textbooks, this is what you see, a lot of words. So what tends to happen here? What if you have students who are maybe not as proficient in literacy? In other words, they have problems reading, right? All of a sudden now, there's a level of complexity there that prevents them from actually doing the mathematics. The other question you might be asking yourself is, if I pose this problem to you and say to you, is this a good math problem? Would you agree or not? Would this be a good math problem?
Maybe.
Ideas? Maybe? Okay. Some say, yeah, I think it's pretty good. Some say, no, it's a horrible math problem because there's no math going on here, right? Is there any higher level mathematics going on here? Well, it may be on how you look at this problem, right? The perspective from which you see. So if we look at this problem, really there's 4 or 5 key things that we need to know, right? What we're looking at here, the figure, the size, and then what is the actual question. And what we can do is we can actually provide a visual to students to help them conceptualize this more, okay? Now this is a problem that's actually given on an international assessment, okay? And for this particular problem, it's one of the lowest scoring problems all over the world. And so researchers are fascinated. Why is this problem so ambiguous to students? Why do you suppose it's ambiguous? And incidentally, my friends, you all said 20,000, okay? The answer is actually 5,000, okay, 5,000. Because there's a bit here that often gets overlooked, and that's that all the fans are standing, okay? Which means that the problem is trying to make you imply that for each square unit, you can actually fit more than one person, okay? Which makes it more people. Does that make sense?
Yes.
Okay, and so what happens is kids don't see this, okay? This is where the disconnect is, all right? And so the challenge then becomes, well, how do we help them see that? If we're math teachers, how do we help them see that? Well, what if we took this problem and simply did something different with it, right? So we're going to go in here. I found this this stadium that you guys have here in this city. And if we go in there, what we can do is I can pose this problem to you in the same way, okay? So here's this city here. And what I want to do is just ask you if the stage is here, and I give you dimensions for this. By the way, we have the real life dimensions here. If I give you dimensions for this, and I make the grid out of it, and I ask you the question, do you think then that becomes more explicit for students than simply just giving them the words? Okay? And so when we think about mathematics, this is kind of the way we have to, perspective that we have to think about, is how do we use media to help enhance the instruction of mathematics. So that's one small example to show you this. So let me go through a couple of more. There's something really, really important that needs to be understood about using these particular technologies. When we talk about interactivity, we can walk into a classroom and see a teacher doing a lot of things, moving things around. Maybe the kids are moving things around and things are happening, okay? But you have to ask the question, other than this kind of stuff where things are moving on the screen, is anything else going on? Okay? And if there's not, then we're not maximizing the potential of these technologies. So I'd like to propose to you three types of interactivity, okay, that we need to think about for all types of lessons that we create, not just mathematics. Typically, we see this, what we call interaction with the interface, which is nothing more than dragging things, clicking on things, and other things happen, actions, right? But when you think about what's going on up here with the students as you're watching the content, if there's nothing going on there, if there's no processes that are being developed, then you're not taking full advantage of what you could do. So what you want to have also are what we call cognitive interactions, okay? And that is how to interact with what you're doing here, what the teacher is doing, interact with what's going on up here with the student. How are they processing the information that you're delivering? And that goes alongside a third type of interaction, which we call socio-cognitive interaction, which basically means what type of student-student and teacher-student dialogues are you having in the classroom, okay? And it's a combination of these three types of interactions that truly form what we typically call an interactive classroom. So to make this a little bit more clear, I'm going to show you just examples of each of these to give you an idea.